Okay, so the next question we're going to solve is the year 2013, paper 1, question 12, right? So the question said, write down a possible equation for each of the sketch graphs below. In each case, select one of the equations from the box above. Okay, so it gives us, the question gives us many equations, and the question asks us to equate the sketch graph with one of the equations in the box. All right, so the question gave three sketch graph. The first one is this, y and x, part A, and then the second one is part B, and the third one is part C. Okay, so we're going to solve one by one. All right, so for part A, right, before we go into that, I would just like to maybe draw a graph just to show you. So whenever you see graphs that are like these, okay, or graphs that are like these, okay, you should notice that this is an x power of cube graph, okay, this is an x power of cube graph. But my question to you is, which one is a positive x power of cube graph, which means, okay, just let me write it down in proper equation, y equal to x cube graph, and which one is a y equal to minus x cube graph. Okay, you can see, right, that the trend of the graph is different. One is upward, the other one is downward, right? So let me just write down. So you see part 1 over here, this is an upward trend graph, whereas part 2 over here, this is a downward trend graph, right? So yeah, so it's either a positive x cube or it's a negative x cube, right? So we like to find out more, and what we can do is that looking at the quadrant, okay, when over here, for example, when x is positive, you can see that y is also positive, right? How about over here, this quadrant? When x is negative, y is also negative, right? So these are the two um, quadrants, right? And we can use that to check, whether it's a y equal to x cube graph or y equal to minus x cube graph. So how about we just check it right now, okay? And maybe I will just do this, separate it to 2. So over here, let's solve y equal to x cube, okay? And over here, we'll write down y equal to minus x cube, and we'll verify whether it's correct or not. Okay, so let's sub in, okay? So when we let y, okay, we let x, okay? Let x be positive, okay? And what do you think is y? Positive. So let's sub in positive 1, okay? So 1 positive 1 cube is equal to 1, right? So when x is positive, y is also positive, right? So let's put here when x is positive, y is positive. But when x, okay, let's see, when x is negative, what is y? Okay, let's check, okay? If again minus 1, you put it over here, minus 1 power of cube. So it's equal to minus 1 multiplied by minus 1 multiplied by minus 1, right? Minus 1 multiplied by minus 1, this is positive. Positive 1 multiplied by minus 1, this is negative, right? So when x is negative, y is also negative. Am I right? All right. So doesn't it, you know, uh, 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 is the same as what we see in graph 1? It is, right? When x is positive, y is negative. Over here it's also when x is positive, y is negative. And in the other quadrant, when x is negative, y is negative. Over here, it's also when x is negative, y is negative. Therefore, it makes sense, right? Say that indeed, y to equal to this graph, right? It's a y equal to x power of 3 graph, right? So let's look at graph number 2. Over here, when we let x to be negative. Okay, so let's look at the quadrant first. Look at the quadrant, and over here, this quadrant, in this quadrant, when x is negative, y is positive, right? So when x is negative, y is positive. How about in this quadrant? When x is positive, y is negative, right? So let's check, okay, whether this um, this equation y equal to minus x cubed is also follows this pattern, okay? So when we let x to be negative, what do we get? Y, okay? Y equal to what? So we have minus. For example, we put in, since x is negative, let's say minus 1 power of 3, right? So again, we have established just now, when it is a minus 1 power of 3, it will be equal to minus 1, right? Minus 1 multiplied by minus 1 is positive 1. Multiplied by minus 1 again is a negative 1. Okay? So this equation, minus and minus, will become a positive. So it's just 1, positive 1, right? So therefore, when x is negative, y is positive. Do you see that? When x is negative, y is positive. Now, if we let x to be positive, what do you think is y? So let's see, okay? We put minus and we put a positive 1 cube. What do we get? It's equal to minus 1, right? So when x is positive, y is negative. X positive, y is negative. And you see how it follows this pattern, right? When x is negative, y is positive. Y is positive, okay? When x is positive, y is negative. When x is positive, y is negative. So it follows this pattern. Therefore, yes, we can say indeed y, this graph, follow the pattern of y equal to minus x cubed graph, right? Okay, coming back to the question. Okay, if you see over here, part A, right? Or there is this kind of graph as well, similar shape as what we just saw. So we know this is an x power of cube graph. But the question is whether it's a positive x power of cube or negative x power of cube. It's a positive x power of cube graph, right? This is a positive x power of cube graph, right? But it's just that, okay, we don't know what is the coefficient, whether it's a plus, and then blah, 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 because it's a sketch, right? It's not an actual graph, so we can solve what's the, y and x. But the question gave us a few equations. So we know from here, okay, from the box, we see that, okay, a positive x power of cube graph, we see over here, sum of it is this, y equal to x power of cube minus 5, okay? We also see y equal to x power of cube plus 5, right? Okay, so let's find out which one is it. Is it a number 1, no? Or is it a number 2? Okay, so let's try to solve, let's try to put in, the x and y intercept, okay, in order to solve. We put let x equal to 0, okay, this is an x, let x equal to 0. What is y? Y equal to minus 5. Okay. Okay, when x equal to 0, okay, over here, when x is equal to 0, right? This is the line, right? When x equal to 0. Oh, the graph, from the sketch graph, we see that y is supposed to be positive number. But over here, from this, by looking at this equation, we see that y is minus 5. So we know already, oh, okay. So that means the equation doesn't fit, okay, this line, because it doesn't follow the pattern, right? So let's just put a cancel over here, means it's wrong. And let's try to solve this. It's very likely to be the equation number 2. But let's just try to solve it so that we know for sure. Okay. So if we let x equal to 0, what is y? Y equal to positive 5. Okay, and let's see. Okay, over here, indeed, right? It's a positive number when x equal to 0. Okay, very likely it's right. How about we try again? Let y equal to 0. Okay, this time around, what is x cubed? X cubed equal to, okay, so put here 0 equal to x cubed plus 5, x cubed equal to minus 5, x equal to minus cube root of 5, right? So when y equal to 0, x is a negative number. So let's check it out. When y is equal to 0, oops, okay, this is the x-intercept, right? And the x is indeed a negative number. We do not know for sure what is a number because, again, this is a sketch. But from the signs, it's quite clear. Okay, it's very likely, right? This is likely a very good guess, And in fact, there is only 2 equations of y equal to positive x cubed graph. And the first one, we know it to be wrong. So the answer is this, number 2. Okay. Okay, for the next part B, we are looking at this graph, a bowl-shaped graph, but an inverted one. Okay, so let's revise first. Okay, what we learned in school. Okay, I'm sure this is what you learned in school, right? There are 2 kinds of bowl-shaped graph. The first kind is a normal bowl-shaped graph, and the second kind is a inverted bowl shape, right? Looks like this, okay? Inverted bowl shape. So and I think you have also learned in school that the normal shape bowl is actually a y equal to x squared graph, and then the inverted one is a y equal to minus x squared graph. But okay, let's just check, okay, to make ourselves sure that indeed the equation of the graphs are correct. So let's see again, using the same kind of method for this quadrant. You can see that when x is positive, just write here like this. When x is positive, we have y to be positive as well, right? How about here? When x is negative, what is y? Y is positive, right? Okay, so let's check it out over here. We let x to be positive. Let's say it's a positive 1, okay? What is y? Y is 1 square. 1 square is 1, right? So it's a positive 1. So y is positive. When x is positive, y is positive. Okay, how about this one? This graph. In this quadrant, when x is positive, we have y to be negative. How about this quadrant? When x is negative, we have y to be negative, right? Okay, so let's see whether the pattern of the equation y equal to minus x squared actually is the same. Okay, let's check. When we let x to be positive first. Okay, let's try positive. And what is y? Okay, we just minus and we put here, for example, positive 1 squared. We realize that it is a minus 1, right? So y is negative. And when we let x to be a negative number, what is y? Okay, y is, for example, if we put in a minus 1 squared, what do we get? Minus, inside here will be 1, right? So minus 1, it's a negative number. So when x is negative, y is also a negative number. All right. Okay. How I think I missed one part over here, right? If we let x to be um, negative over here, what is y? And we realize that, if we put in, for example, a minus 1, minus 1 square is equal to 1, right? So it's a positive number. So when x is negative, y is positive. Okay, and indeed, right, you can see, right, it follows this pattern. When x is positive, y is positive, positive, positive. X is negative, y is still positive. X negative, y is positive. Okay, so y equal to xy, yeah, it makes sense. It is equal to, it is the same. It represents this bowl-shaped graph, and the inverted bowl-shaped graph. You can see that when x is positive, y is negative. Yes, when x is negative, y is negative, and yes. Okay, so y equal to minus x squared. Yes, it represents the inverted bowl-shaped graph. Okay, so coming back to the question. This is an inverted bowl-shaped graph. So we know this is a um, um, y equal to, this is a minus x squared graph, okay? I'll just write it down like that, minus x squared graph, okay? But, we need to find out, what is y equal to, the coefficient of the x, and then also the constant in that equation, what is it, right? But when you check the box, you realize that there is only one, a negative x squared equation, which is this one, right? So y equal to 5 minus x squared. This is the only one. So it's very likely to be correct. In fact, it's the correct answer. But let's just check it out. Okay, for example, in the exam, you just want to really make sure that, okay, yes, this is the one. So what do? You test with the y and x intercept, right? You let x equal to 0. What is y? Y is a positive number, positive 5. So let's see, when x is equal to 0, oh yes, indeed, y is a positive number. Okay, so when we let y equal to 0, what is x? Okay, we realize that 0 equal to 5 minus x squared, and x squared equal to 5, x is equal to plus or minus square root of 5. So it's a positive or negative number when y is equal to 0. So over here, when y is equal to 0, we see that x indeed is a positive and negative number. There are two x intercepts for this graph. So yes, this equation is correct. Y equal to 5 minus x squared. Okay, again, you cannot verify it for sure, like it is in a graph, paper, those kind, because this is just a sketch. So you got to guess. You got to do it by elimination as well in order to get to the right equation. Okay, for part C. Okay, so this is again a graph of another shape, right? So let's do a bit of revision again. Maybe you have learned this in school before. You can see that there are two types of graphs, right? One is again an upward kind of graph, and then the graph 2 is a downward kind of trend of graph, right? So you can see over here, I put here the equation y equal to c power of x for graph 1, and for graph 2, y equal to c minus power of minus x. Okay, so what is c? C is a constant, right? It can be 1, 2, 3, 4, 5, any number. Okay, and if you look at the graph, you realize that actually, okay, let's solve it one by one. Okay, so over here you realize that when x is a positive number, right, when it increases, you realize that y is also a positive number, but it is an increasingly large positive number, right? You can see from the upward trend graph, right? And in this quadrant, you see that when x is negative, you realize that y is still positive, but it's a very, very small positive number, right? Very, very small. In fact, over here, if you see, if I can illustrate further, I would like to, the y is actually approaching zero, but it's not reaching zero, right? It's just approaching zero. And if you want to test it out over here, you can see, okay, so for example, let's sub in an equation, okay? Let's say, similar to our question, they say y equal to 5 power of x, right? So let's just put it, y equal to 5 power of x. So when x, for example, it's 2, right? When we let x is equal to 2, we realize that y equal to 5 square. 5 square is equal to 25. But if we let x equal to 10, okay, we multiply it by 5, you realize y becomes a very, very large number, 5 power of 10. What is a 5 power of 10? It's a 9,765,625. Wow, we just multiply x by 5 and realize that y becomes a very, very huge number. This is not a factor of 5 from 25 to 9 million, right? So, it follows this pattern, right? When x is positive and it's increasing, y is increasing at an increasing rate. Okay, so how about when we put x to be negative? Okay, let's check it out. When we let x to be a negative number, let's say a negative 2, then we let y, y becomes 5 power of 2, power of negative 2, which is equal to 1, 5 power of square, okay, which is 1 over 25. But if we let x to be equal to minus 10, for example, we notice that y becomes an increasingly small number, a very, very small number. So 5 minus 10, right? It's equal to 1, 5 power of 10. No, just now we put here 1 over, we just check, right? 5 power of 10 is 9 million, right? So 1 over 9 million is a very, very small number. It's almost zero, but it's not zero, It's still positive, but very small. So it follows this pattern, right? A pattern of graph number 1. Okay, maybe it's better if I use another color. Just use green. Y equal to c minus x. So let's see, okay, for the graph number 2. Y equal to 5 minus x, for example, and let x, and over here you can see, right, that when x is a positive, y is also positive, but a very, very small positive number, right? In fact, reaching 0 as x increases, right? So over here, I should maybe make the sign positive very, very small. This is a normal x, and this is a very, very small positive number. Okay? And over here, when x is negative, right, and increasingly negative, right, as it decreases, you realize that y becomes a very, very large positive number, right? So let's check out this pattern over here. When we let x equal to, for example, equal to 2, okay, we get y is equal to 5 minus 2, which is 1 over 25. But when we let x equal to, for example, 10, raise y equal to 5, my power of minus 10, 1 over 5 power of 10, and this is a very, very small number, 1 over 9 million, right? So when x is positive and increasing positive, we realize that y is positive still, but it's, you know, it is approaching zero, a very very small positive number, right? So let's see when x is a negative number, what is y? We will let x equal to, let x equal to minus 2, for example, y becomes what? 5 minus minus 2, so it becomes positive, right? Equal to 5 squared, which is equal to 25. And when we let x equal to 10, for example, minus 10, sorry, minus 10, okay? What is y? Y equal to 5 minus minus 10, right? So it is equal to 5 power of 10, which is 9 million, right? Which is what we solved just now. 5 power of 10 is 9 million. So when x is a negative number, y becomes increasingly large, you know, which follows this pattern, right? So it becomes a very, very large number. So we just prove that yes, indeed, when x, you know, the graph number one seems to follow this pattern: y equal to c power of x, and again, c is the constant. It can be 2, it can be 5, it can be 7, 10, and yeah, whatever it is, it's just a constant. Okay, so when y is you know, when the graph of the this graph is going down, it's a downward trend and it's approaching zero, you know, as x approaches a positive number, you realize that this equation is the one that describes it, which is y equal to 5 minus x. Okay, so coming back to the question, this graph is an upward trend graph, right? So which one is it? Okay, again, there is only one graph, one equation that is like this, right? The rest is x squared, x cubed, and we just solved it in earlier parts, right? So this is likely to be 1, 5, y equal to 5 power of x, as we have proved just now.